everybody, it's Mike. Just wanted to explain a few challenging Desmos questions. As you can see, we have one here up on the screen, and I'm just going to go ahead and copy all four of these answer choices straight into Desmos and see what they look like on the graph. So let's go ahead and do that. Now it does say R is a positive constant, so I'm going to use R, but then we're going to replace R with, or we're going to determine R using a slider. So that's usually pretty easy in Desmos. In fact, there it goes, asking me right away if I want to make R into a slider, and I do. All right, now let's add the other equations. So we have Rx minus 18y equals negative 36. And then we have 18x plus ry equals 36. And finally, we have 18x minus ry equals negative 36. All right, so now we can just start playing around with R. It says R must be a positive constant, so it is here, but as we adjust R and make it more positive, increase its value, you can see that one of the answer choices, the line that is colored black, which is the third one, is now perfectly matching the graph here in the question. As you can see, its y-intercept is 0, 6. This y-intercept is 0, 6, right? And its x-intercept is 2, 0. You can see the x-intercept is 2, 0 here. So the correct answer is C, the third one, and we found it by typing in all of the answer choices into Desmos, using R as a slider constant, and then just adjusting it until one of the lines matched up perfectly with what the question was asking us. All right, here we're looking at another SAT question, and as you can see, it involves giving us two functions and then combining them. So function number one is f of x equals 1/4 x minus 9, and function 2 is g of x is equal to 3/4 x plus 21. And now they say that h of x is going to be the sum of f of x and g of x. All right, so how are we going to set that up? Well, we know that one of them is 1/4 x minus 9, and we're just going to add to that the other function, which is 3/4 x plus 21, and that's going to give us x, and then plus 21 minus 9, so x plus 12. So we know now that h of x is equal to x plus 12. So it's sort of randomly graphing a lot of these, which is cool, but we don't need these graphs here, so we can just get rid of those. All right, so we now have this, h of x is equal to x plus 12, and the question asks us for the x-intercept. We can just see right here that it is negative 12, 0, which makes sense because when we're figuring out what the x-intercept is, that means that y must be equal to 0. So we would rewrite this as 0 equals x plus 12. And that means that x must be negative 12. All right, let's take a look at another Desmos-based question. All right, so the question tells us that oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. So we'll need that information later, but we know that this is a descending line. Okay, since we know it's a descending line, right away we can get rid of answer choices A and B. Those are both positively sloped lines. I mean, you know, they have a positive slope, either 21 1/30 or 19 1/30, right, and a positive y-intercept, but these are positively sloped lines, and this is declining, oil and gas production. So it's going to need a negative slope. So really, we're just trying to answer whether or not the question is looking for answer choice C or D, and that's all. So those two answer choices only differ based on their slope, so we really need to figure out what the slope is. Well, the slope is going to be the change in y over the change in x. So it's going to be the change in oil production, which is 4 minus 1.9, divided by how many years it was, 13, right? This gives us the slope, 4 minus 1.9 divided by 13. But unfortunately, it's in this decimal that we can't really use because all of our answer choices here have fractions as their slopes. But there is this handy dandy button here in Desmos, this button right here. And if you press it, boom, it will give you the answer as a fraction. So now, without any further effort, we know that the correct answer must be C. All right, so let's take a look at another question. Here we're given a function that translates Fahrenheit into Kelvin. So that's pretty cool. We can just go ahead and type this expression right in here. That's going to be equal to 9/5 of x minus 273.15, close paren, plus 32. All right, so this gives us a graph, but it's not really clear what the utility, what the use of this graph is going to be. I mean, think about it. The question is only asking us what happens when I increase the temperature by 2.1 kelvins, right? So, I mean, we have a line, but that doesn't really help us answer the question. Let's try plugging in numbers. Let's say that x is equal to 273.15. Right? If x is equal to 273.15, I mean, you can just go ahead and figure this out. I mean, 273.15 minus 273.15 is going to give us 0. That's why I picked it. 0 times 9/5 is 0, plus 32 is 32. So if we say that x is equal to 273.15, then our output is going to be 32. Very good. What happens when I increase the temperature by 2.1 degrees? Well, if I start with x is equal to 275.25. Well, 275.25, let's go ahead and just plug it in manually. 275.25 minus 273.15. Put that in parentheses, right? Multiply it by 9/5, and you already have the answer, right? We can go ahead and add 32, but you know, the temperature has changed from 32 to 35.78. So we can see that the correct answer must be A, but I think there's a little bit more to this question. I think that it's actually easier than having to go ahead and plug it all in and whatever. Just look at it. You can see that in this equation, 9/5 times some number that's being subtracted from the number that you're given, the number in Kelvin degrees that you're given, we're subtracting 273.15 from that. Then we're multiplying it by 9/5. All right. So if the degrees are being subtracted, then their size isn't changing. But if the degrees are then being multiplied by a fraction, now their size is changing. Well, how much of a fraction are they being multiplied by? 9/5. So not quite 2, right? So 1 4/5. So we're going to make these degrees bigger, but we're not going to make them that much bigger. So if we increase the temperature by 2 kelvins, the answer out of these choices, 3.78, 35.78, and then numbers that are just far, far too big, we know the answer has to be 3.78 because it's the only answer choice where the degrees are even remotely close to the size that the degrees were at the input part of the equation. So that's sort of another way to think about this, which is to realize that, yes, we're adding and subtracting numbers from these degrees, but that's not going to change the size of them. The only thing that changes the size of them is multiplying them by a fraction, and that fraction is not even 2. It's less than 2. So the degrees, each degree won't even be 2 degrees on the new scale. So if we are changing the scale by 2.1 Kelvin, we'll be changing it by 3.78, you know, something less than 4 approximately. And that will be the output. So you can sort of approach this using, you know, strict Desmos, or you can kind of try to apply your common sense. I'm a big fan of using common sense to provide us with shortcuts on math questions. And I think a really excellent way to understand this question and the two different approaches that we have here is to ponder it, which means to sit and stare at the question and try to work your way through the things mentally. I mean, 273.15 minus 273.15 is not that hard to do in your head. You know, those numbers disappear. So you can sort of sit and ponder this and try to give yourself a deeper awareness, a deeper understanding of why the answer really has to be A here. So I hope you got a lot out of that. And I'm going to go ahead and post some more of these just because I'm so fascinated with how incredibly powerful Desmos is when you use it on appropriate questions on the SAT.